Welcome dear student to my YouTube channel. It's just mathematics. In last two lecture of derivative, we covered definition of derivative, the physical meaning as well as the geometrical meaning of derivative. What is the physical meaning? It tells the instantaneous rate of change of a function with respect to its independent variable, right? So this was the physical meaning. And what was the geometrical meaning? Geometrical meaning says that derivative is nothing but the slope of the tangent line drawn to the given function at a given point. Okay, that means हमको मन रखा पड़े जे derivative slope of the tangent हमको provide करे at a point. That is the geometrical meaning. Okay, so after geometrical meaning, what we covered? The standard formulas of derivative. There are 17 standard formulas. Everybody has to remember. Otherwise, while finding the derivative of complicated problem, we will stop in between. Okay? So that's why everybody has to memorize all these 17 formulas. As a result of which, the flow can be maintained throughout the chapter. Okay? So after that, we started chain rule. What was the chain rule? Why we will go for chain rule? आमे chain rule केतोले अप्लाई करिवा जेतोले गुटे गिवन फंक्शन डायरेक्टली x रो फंक्शन नथिबो. Okay, let's say I am telling here, observe y is equal to ln sin x. If it would be y is equal to ln x, so here this function is directly function of x, and when the given function is directly function of x, we are having standard formulas. But here sin x is there, which is making problem here. तो हमको कौन करिया पड़िबो? हमको कौन करिया कि जो सम अदर क्वांटिटी टा हमको प्रॉब्लम करूची ताको हमें आउ किछि वेरिएबल ले सब्स्टिट्यूट कर दवा. लेट्स से sin x is equal to z. That means y will be sin z. So here y is directly function of z. Our aim is to find dy by dx. So according to chain rule, this can, as the y is directly function of z, we have to differentiate y with respect to z. Then z is sin x, that means directly function of x. So z can be differentiated with respect to x, right? So just applying this formula, this is nothing but the chain rule. We can find the derivative of a composite function. When the function is not directly function of x, that function is called composite function. Okay. So how we have to find out? Observe here, dy by dz will be how much? Cos z. Okay, then dz by dx will be how much? Here z is sin x, so its derivative will be cos x. Sorry, here there is one mistake. This will be ln z. Okay, so derivative of dy by dz will be 1 upon z, or 1 by z. Then dz upon dx will be cos x. What is the value of z? Sin x. So put here cos x by sin x. So derivative will be cot x. This is method 1. In method 2, we have to find its derivative directly. How? Just observe. First write the function. Whenever the given function is not directly function of x, then we have to put large bracket and small bracket. Let's say here small bracket is there, put one more large bracket. Here what we are observing, the y is a function of sin x. First we have to differentiate the given function. First we have to differentiate the large bracket, then differentiate the small bracket. Then we have to differentiate the large bracket with respect to small bracket. Here small bracket is sin x, okay, the term inside the small bracket. That means we have to differentiate ln sin x with respect to sin x, and again differentiate the small bracket with respect to x. So directly we can write dy by dx will be, when we are going to differentiate large bracket with respect to small bracket, that means ln sin x with respect to sin x. If it is ln x with respect to x, what is our formula? 1 by x. So accordingly here will be 1 by sin x, okay, into derivative of small bracket with respect to x. So small bracket means sin x, with respect to x its value will be cos x. So answer is cot x. Getting? Here also cot x, here also cot x. You can find which method is suitable. Let's do in one more method, method 3. Here the given function is function of sin x, then sin x is a function of x. Then we have to break in that manner. Dy by dx will be derivative of ln sin x with respect to sin x, again derivative of sin x with respect to x. Our target is to obtain derivative of ln sin x with respect to x, and this will be equal to derivative of ln sin x with respect to sin x will be 1 by sin x, and derivative of sin x with respect to x will be cos x. So answer is cos x. Which method is suitable for you? Go for that method. Let's solve few more problems based on chain rule. I am taking few problems from the exercise 7C element. Everyone observe. Let's say we are having function. Am pakhre kon function achi? X square plus 5 to the power 8. Okay. This is not a direct function of x, because if it would be x to the power 8, no problem. We can solve it directly just by applying the formula, derivative formula of x to the power 8. But here the quantity x square plus 5 is making us trouble. So what we have to do is that we have to take this one as some other variable. Let's say I am taking this one. Let x square plus 5 is equal to u, let's say. Okay. Then y will be how much? U to the power 8. So here y is directly function of u, direct function of u. That means we can differentiate y with respect to u, no problem. And again you observe u is x square plus 5, which is a direct function of x. That means we can differentiate u with respect to x, no problem. So applying chain rule, what we have to find out? Dy by dx will be dy by du, because y is directly function of u. Again du by dx. Okay. So how much will be dy by du? Just differentiate u to the power 8 with respect to u. 8 into e to the power 7. As I have told, power will come to the left and there will be decrease 1 in the power, into derivative of du by dx, that is nothing but 2x. Just replace value of u here, x to the power 5 to the power 7 into 2x. So answer will be how much? 16x whole into x square plus 5 to the power 7. So this is the final answer. Getting everyone? So let's solve one more problem. This was method 1. In method 2 I am solving, just observe. method 2, write the function first. What we have to do here? The bracket concept. First we have to differentiate the large bracket with respect to small bracket against small bracket with respect to x. Okay. If the small bracket is direct function is function of x, that is the condition. Otherwise we have to take one more time one more small bracket. Let's see how I am solving. Dy by dx will be, observe everyone, directly I have to do the derivative of large bracket. Let's say this is u to the power 8. This will be 8 e to the power 7. So just replace the value of u. Again, derivative of small bracket with respect to x, that is 2x. So direct answer 8 16x x square plus 5 to the power 7. Okay. Method 3. In method 3, dy by dx will be replace the value of y, x square plus 5 to the power 8, derivative of whatever to do. Here this is function of x square plus 5. So first differentiate with respect to that. Again differentiate x square plus 5 with respect to x. So answer will be, if here it would be x to the power 8 with respect to x, the answer will be 8x to the power 7. So similarly 8 into x square plus 5 to the power 8. Okay, and the derivative of this one will be 2x. So answer is 16x x square plus 5 to the power 7. Getting everyone? So let's solve one more problem from the element book, question number 2, exercise 7c. The question is, the question is 1 upon x square plus sin x the whole square. So this can be written as x cube plus sin x to the power minus 2. Here the given function is not direct function of x. Here it is function of x cube plus sin x. So let's solve this one in first method. Dy by dx will be dy by du into du by dx. Here take x cube plus sin x is equal to u. Y will be e to the power minus 2. Okay, so dy by d will be how much? Minus 2 into e to the power minus 3. And du by dx will be how much? Here this quantity is direct function of x, so we can differentiate with respect to x. Here its derivative will be 3x square plus cos x according to addition theorem. So just put the value here. Here the answer will be replace the value of u, x cube plus sin x to the power minus 3 into 3x square plus cos x. So our answer will be minus 2 upon x cube plus sin x to the power 3 and 3x square plus cos x. Okay, let's solve one more problem. Question number 3 from element book. here the given function is y is equal to ln root x plus x. Okay, so here this quantity is making problem, so substitute that one to some other variable. Let's say root x plus 1 is equal to u, or y will be ln u. Here y is direct function of u, so we can find out the derivative of y with respect to u. This will be 1 upon u, and I can find here u is direct function of x, so du by dx will be 1 by 2 root x plus 0. As 1 is a constant quantity, its derivative will be 0. So according to chain rule, dy by dx will be dy by du into du by dx. Some may take this one as t, v, w, x, anything, but accordingly you put here that value. So du by du will be 1 upon u, and du by dx will be 1 by 2 root x. So replace the value of u, that is 1 by 2 root x, and the value of u will be root x plus 1. So our final answer will be, just multiply this quantity here, 2x plus 2 root x. This is our final answer. So this will be our final answer. Everyone make one note. The derivative of root x is equal to 1 by 2 root x. This one will be used maximum time. How it is becoming, I am explaining here. So root x can be written as x to the power half. So put x to the power n formula, n into x to the power n minus 1. So this is equal to half into x to the power minus half. So half into 1 by x to the power half. So this can be written as 1 by 2 root x. Okay. So here is the formula. Everyone memorize this one. Take it as formula number 18. So write in the standard formula. So let's solve one more problem. Everyone observe here. Here the question is y is equal to sin 5x plus cos 7x. So we have to apply the addition theorem. That means when two functions are added together, then their derivative will be, just add the derivative of individual derivative, just as the add the individual derivative. हम कौन करिया हुआ कि derivative काढ़िबा, then individual function लो sin 5x रो derivative काढ़िबा, cos 7x रो derivative काढ़ी कि just add करते हैं. That means derivative will be dy by dx will be dy by dx of sin 5x plus dy by dx of cos 7x. This is from theorem 1. But what we are observing here, here the given function is not direct function of x. Here it is function of 5x. What we have to do? First we have to differentiate with respect to 5x. So how much it will be? Directly I am writing cos 5x. Again the derivative of 5x, that is 5. So what we are observing here, the constant quantity that is multiplied with x, that will come outside, and just assume this one as sin u, and then its derivative will be cos u. Just put value of u, that is 5x. Again here derivative of cos 7x. If it would be cos u, its value will be minus sin u, and the value of u is 7x. Again derivative of u, that is derivative of 7x is 7. I am writing that part directly. It will be sin 7x into that constant will come out. So answer will be 5 cos 5x minus 7 sin 7x. Okay. So this will be our answer. Directly I am writing, no problem. Try to practice lots of problems so that you will be in a position to write the derivative of every function directly. So it needs lots of practice. Then solve question number 5. Y is equal to e to the power sin t. Here observe everyone. Here the function is t is there. So we have to differentiate with respect to t. That is dy by dt we have to find out. But here e to the power sin t is not a direct function of t. Here it is a function of sin t. First we have to differentiate with respect to sin t. Again derivative of sin t. Okay. So how we have to write? Directly I am writing. Otherwise solve in fast method. Then I will write directly. So stack sin t is equal to u. So y will be e to the power u, and dy by du will be e to the power u, and du by dt will be cos t. Okay, just put dy by dt will be dy by du and du by dt. This is from chain rule. So put everything here. Dy by du will be e to the power u, and value of e to the power e is how much? E to the power u, e to the power sin t. Replace the value of u. E to the power sin t into du by dt is cos t. So this is our final answer. In method 2 you have to write directly. E to the power sin t is there. So dy by dt will be, first we have to differentiate e to the power t with respect to sin t. E to the power sin t with respect to sin t. This value will be e to the power sin t. Again into derivative of sin t, that is cos t. So this will be our answer. Let's solve question number 6. Y is equal to ax square plus bx plus 0 square root. Okay. So this can be written as ax square plus bx plus c to the power half. As we know that the derivative of root x is equal to 1 upon 2 root x. So directly we can write the derivative of root x is 1 upon 2 root x. Just derivative of this will be, let's say this one is root u. So 1 upon 2 root u value is this one. So this will be ax square plus bx plus 0 square root into derivative of u, that means derivative of ax square bx plus c. So this will be 2x plus b. Okay, so our final answer will be how much? 2x plus b by 2 square root of x square plus bx plus c. This is our direct answer. Let's solve one more problem. Here y is equal to, y amar kon achi, x plus 1 by x square plus 3 to the power minus 3. Okay, just take this one u. So apply chain rule. Dy by dx will be derivative of this one, that is, let's say this will be e to the power minus 3. So that derivative kete hobo? Minus 3 into e to the power minus 4. That is u bodole replace kariya padibo x plus 1 by x square plus 3 to the power minus 4 into derivative of this form ta achi, tar derivative kadiba. तार डेरिवेटिव काढिया पे हमको कौन डिवीजन रूल अप्लाई करिया पड़े. दुईटा फंक्शन डिवाइड हो गछि, तो स्क्वायर ऑफ डिनोमिनेटर इन न्यूमरेटर डिनोमिनेटर इनटू डेरिवेटिव ऑफ न्यूमरेटर. डेरिवेटिव ऑफ न्यूमरेटर विल बी x plus 1 लो डेरिवेटिव केते 1 माइनस न्यूमरेटर इनटू डेरिवेटिव ऑफ डिनोमिनेटर. डिनोमिनेटर डेरिवेटिव केते 2x. So this will be minus 3 into x plus 1 by x cube plus 3 to the power minus 4 into, solve the numerator part, x square plus 3 minus 2x square minus 2x upon x square plus 3 to the power 2. Then simplify this expression. Okay, so finally we have to simplify as much as we can. Okay, let's solve one more problem. Question number 8 from exercise 7c. Y is equal to sec of tan theta. Okay, so here it is function of tan theta. First we have to differentiate with respect to tan theta, again tan theta with respect to theta. So directly I am writing dy by d theta will be differentiate tan of tan theta, sec of tan theta with respect to tan theta, that will be sec of tan theta into tan of tan theta. That means if it would be u here, the derivative of sec u with respect to u will be sec u into tan u. So just replace the value of u here. The again derivative of tan theta, that is sec square theta. So answer will be sec of tan theta into tan of tan theta into sec square theta. Okay, so solve one more problem. Question number 9. Y is equal to sine of 1 minus x square by 1 plus x square. Okay, so just will do directly. Dy by dx will be, take this one as u, so derivative of sine u with respect to u, that will be cos u. So put the value of u here, 1 minus x square by 1 plus x square. Again derivative of u, that is, we have to apply division formula. The square of denominator into derivative of numerator minus 2x minus numerator into derivative of denominator, that is 2x. So solve this expression. Here take minus 2x common. How much we are getting? 1 plus x square plus 1 minus x square upon 1 plus x square. Okay, so this will be cos of 1 minus x square upon 1 plus x square into minus 2x into, this will be cancelled out, into 2 by 1 plus x square. So final answer will be minus 4x upon 1 plus x square into cos 1 minus x square by 1 plus x square. Getting? So this is our final answer. So this will be our final answer. This cannot be simplified further, so leave the answer here. Okay, so one more problem I am solving. Here the question is y is equal to square root of tan 3z. That means here the variable is z, that means we have to differentiate with respect to z. Dy by dz will be. So let's say this one is u. The derivative of u, root u, with respect to u will be 1 by 2 root u. Just replace the value of u, that is tan 3z. Again derivative of tan 3z, this will be sec square 3z. Then again we have to apply chain rule, that is derivative of 3z, that is 3. So answer will be 3 sec square 3z upon 2 into square root of tan 3z. 2 into square root of tan 3z. This much. Again I am explaining. Here this is function of tan 3z. Again tan 3z is function of 3z. Okay, and again 3z is function of z. 3 times we have to apply chain rule. First differentiate this one with respect to tan 3z. Again tan 3z with respect to 3z. Again 3z with respect to z. This is how we have solved. Okay, so solve one more problem. Here the function is y is equal to tan qx. This can be written as tan x to the power 3. Okay, differentiate tan x to the power 3 with respect to tan x. Again tan x with respect to x. Directly I am writing dy by dx will be, just take this one u. U to the power 3 means 3u square plus the value of u here into derivative of tan, that is sec square x. So answer will be 3 tan square x into sec square x. Okay, this is will be our final answer. Solve question number 12. Here the question is sin 4th x. This can be written as sin x to the power 4. Okay, so derivative will be derivative of sin x to the power 4 with respect to sin x. Again sin x with respect to x. So 4 sin x to the power 3 into derivative of sin x with respect to cos x, that is 4 sin qx into cos x. This will be answer. So now we have to write directly the derivative of every function. Let's solve this one. Here one can solve applying multiplication theorem. Otherwise, let me modify the initial function. How we can go for? Just multiply floor and divide the floor. Okay, so this can be written as 2 sin x cos x to the power the whole square by 4. Okay, so 2 square 4 sin x square sin square x cos x square cos square x. Okay, then this is the formula of sin 2x. whole square upon 4. Okay, so y is equal to this much. Then dy by dx will be how much? 1 by 4 will be taken outside as constant. 2 sine 2x into derivative of sine 2x, that is cos 2x. Again derivative of 2x, 2. So answer will be, this thing cancel out. Sine 2x into cos 2x. This much will be answer. Just multiply 2 and divide 2. So answer will be 1 by 2 sine 4x. Here the given function is y is equal to square root of sine root x. Here we have to apply 3 times sine rule. How? Here the given function is function of sine root x first, and again sine root x is function of root x, again root x is function of x. So let sine root x is equal to u and root x is equal to v. Okay, so this y will be how much? Square root of u, y will be. Then dy by du will be how much? 1 by 2 root u. Again du by dv will be how much? Cos root x. Here u will be sin v. Why? As the value of v is equal to root x, so u will be sin v. So now dy by du will be 1 by 2 root u. 1 by 2 root u. Okay, and du by dv will be cos v. Cos v, replace the value of v, that is cos root x, and this will be 1 by 2, replace the value of u, sin root x. Okay, and again dv by dx, how much? Value of root x, v is root x, so 1 by 2 root x. Now apply chain rule. Type dy by dx is equal to 3 times chain rule, dy by du into du by dv into dv by dx. Why I am writing like this? As y is the function of u is the function of v, and v is the function of x. Every value, all the values we have calculated, dy by du is equal to dy by du is equal to 1 by 2 square root of sine root x into du by dv is equal to cos root x. Again dv by dx is equal to 1 by 2 root x. So this value will be cos root x upon 4 root x square root of sin root x. Okay, directly we can go for the derivative. Dy by dx will be, observe everyone, as this is the direct function of sin root x. So this will be 1 by 2 root x. So put the value of x, sin root x, into derivative of sin root x with respect to root x. This will be cos root x. Again derivative of root x with respect to x. This will be 1 by 2 root x. So just simplify this one. This will be cos root x upon 4 root x sin root x the square root. Okay, so same answer we are getting. Here see question number 23. Y is equal to ln 10 of 5 by 4 plus x by 2. Here this is direct function of 10 5 by 4 plus x by 2. Again 10 5 by 4 plus x by 2 is a function of 5 by 4 plus x by 2, and 5 by 4 plus x by 2 is a function of x. So 3 times we have to apply the chain rule, and that means dy by dx will be derivative of ln 10 5 by 4 plus x by 2 with respect to 10 pi by 4 x by 2 will be 1 by 10 pi by 4 plus x by 2 into derivative of 10 pi by 4 x by 2 with respect to 5 by 4 plus x by 2 will be sec square 5 by 4 plus x by 2 into derivative of this quantity with respect to x will be half. Okay, this can be written as sec square can be written as 1 plus tan square 5 by 4 plus x by 2, and in denominator it will be 2 tan 5 by 4 plus x by 2. So this is equal to, this is the formula of everyone observe. This can be written, this by this can be written, this quantity can be taken here, that means 1 by 2 tan theta by 1 plus tan square theta, if we take this one theta. So this is the formula of sin 2 theta, so 1 by sin 2 theta. How much is theta? How much is theta? 5 by 4 plus x by 2. Okay, so just simplify this one. 1 by sin 2 into 5 by 4, 5 by 2 plus 2 into x by 2 x. So this is equal to 1 upon 5 by 2 plus x cos x. So 1 upon cos x is equal to sec x. This is the final answer, means simplified answer. Then solve one more problem. Let's solve question number 25. Everyone observe. Here this is ln e to the power nx plus e to the power minus x. That means here this is function of e to the power nx plus e to the power minus nx. Again e to the power nx plus e to the power minus nx is a function of x. So let's differentiate directly. Dy by dx will be, if this quantity will take u, so this will be 1 by u, that is 1 by e to the power nx plus e to the power minus nx into derivative of u with respect to x, that is e to the power nx into n, as constant will be multiplied, plus e to the power minus nx into minus n. Okay, so how much we are obtaining? Observe, n will be common here, n will be taken outside, e to the power nx minus e to the power minus nx upon e to the power nx plus e to the power minus nx. So this is the final answer. Let's solve question number 21. Here the function is y is equal to e to the power 3x square upon ln sin x. So first we have to apply the division theorem, that is square of denominator into derivative of numerator. The derivative of e to the power 3x square will be e to the power 3x square into derivative of 3x square is equal to 6x minus e to the power 3x square into derivative of denominator, that is 1 upon sin x into derivative of sin x cos x. So simplify this one. E to the 3x, e to the 3x square will be taken outside. Then the terms remaining inside the bracket are 6x ln sin x minus cot x upon ln sin x square. So this will be our final answer. Let's solve question number 30. Here question is, prove that dy by dx, that is derivative of 1 minus tan x upon 1 plus tan x half, that means square root of this quantity, will be, we have to show that minus 1 upon square root of 2x into cos x plus sin x. Okay, so this is the function. We can modify this one, just replace sin x can be sin x by cos x, sorry, tan x can be written as sin x by cos x, and here put tan x is equal to sin x by cos x. So simplify this quantity, just take the LCM, cos x minus sin x upon cos x plus sin x upon cos x. Cos x will cancel out, and the remaining term will be this, and there will be to the power half. Power half will be here. That means square root of this quantity. Now we have to derivative this one. So differentiate this one with respect to x. Let's say this one is u. That means square root of u will be how much if you are going to differentiate with respect to x? 1 by 2 root u. So replace value of u here, and into derivative of the quantity inside the bracket, जो क्वांटिटी ब्रैकेट भीतर अछि अगेन तार डेरिवेटिव करबा दैट मींस एठी हम कोन ऑब्जर्व करछन डिवीजन फार्मूला दैट स्क्वायर ऑफ डिनोमिनेटर into square of derivative of numerator. Derivative of cos x minus sin x will be minus sin x minus cos x, again minus into numerator into derivative of denominator will be minus sin x plus cos x, that I have written here. Okay, so this will be 1 by 2 times of square root of this. What we are observing here, take minus outside, sin x plus cos x square, this minus we have taken outside, plus cos x minus sin x square, a plus b whole square plus a minus b whole square, a plus b whole square plus a minus b whole square. The formula is 2 whole into a square plus b square. So here the answer will be minus 2 whole into a square plus b square. As we know, this is a trigonometric identity, sin square plus cos square is equal to 1. So replace this one here. This can be written 1 by 2 into square root of numerator by square root of denominator into here minus 2 because this value is 1, and this can be written as cos x plus sin x into cos x plus sin x, and that I have read here. Okay, then we'll cancel here. एठी गुटे कोन अछि स्क्वायर रूट अछि, एठी हमें जदि कैंसिल कर दबा एठी आउ केते रहइबो स्क्वायर रूट केवल गुटे रहि जिवो, से स्क्वायर रूट ता एठी हमरो लेफ्ट आउट हे जाय. ओके, एंड दिस क्वांटिटी इज रिटन हियर. ओके, देन cos x minus sin x, then cos x minus sin x ro root over into cos x plus sin x ro root over. तो केते हबो ए दीटा मल्टीप्लाई हे जिवो, मल्टीप्लाई हैला पर केते हबो cos square x minus sin square x रो रूट ओवर into cos x plus sin x. हम जानचंती cos square x minus sin square रो रूट ओवर केते cos 2x ऊपर माइनस थिला and into cos x plus sin x. This is the proof. Okay, this is the final proof of this question. Dear student, today we completed the exercise 7C, and till so far we have completed the concept of derivative, that is from definition, and the geometrical meaning of derivative as well as physical meaning of derivative, then the standard formulas of derivative and the chain rule. So we have covered this concept, and in the next class we will learn the derivative of inverse trigonometric function and differentiation using substitution method. It's finding the derivative using substitution method. Okay, in the next class we will study these two concepts. Okay, and if you guys are enjoying the videos, then like, share and subscribe to my channel, and don't forget to press the bell icon to get notified. Okay, so let's stop the class here. Vande Mataram, Jai Hind.